Today, let's go over a medium question that I just solved by myself. I will warn you that my solution is a bit messy, so bear with me, but I did do it. So basically here, the ask is pretty simple. You're given a prices array and a profits array. So each price links to the respective profit, and your job is to find the maximum profitable triplet where the prices are all less than each other. So 2 is less than 3 is less than 4, and the indexes are less than each other as well. So a brute force approach, if the constraints are small, would just be to say if the length of prices is, say, less than 100, and the length of profits is less than 100, you can just do a triple loop, right? And stick the J pointer right in front of the I pointer, so you know that the indexes are matching. For k in range j plus 1, length of prices. And now you can just take the maximum profitable triplet. So result equals to max of result and profits I, right? The respective profit that's matching, plus profits of j plus profits of k. And at the end, after you go through all the possible triplets, if the result didn't change, then there's no matching triplet, so return -1. Otherwise, return the result. So that's going to work for a small subset of problems. Let's see what's going on. So, okay. So if prices... Okay, well, I missed the condition. If prices I, the values have to be less too, right? So I is less than prices j, which is less than prices k, then we can do this. So that's not going to work because obviously the constraints are a lot bigger. So cool. So now let's think of another way to do this. So let's try to split, let's map the prices to the profits in a dictionary first, right? And let's create a default dict of type sorted list so we can get the biggest profit for that particular number. So let's go through prices. And so dp equals to profits of I, right? So let's print d just so you can see. Okay, let's use this test case. So basically we're mapping 10, 200, 2 to 2, 3 to 7, 4 to 10, so we can get the profits of the price. And now let's go ahead and create a lefts and rights sorted list. Of, let's say, prices, because now we want to just use these as the middle, and then everything to the left side, everything to the right side as well. And then we also want to get the maximum profitable triplet of both sides. So I'll show you what I mean. Let's iterate over prices, and let's say, let's print lefts and rights. So, okay. Of prices, yes. Sorted list. So cool. So now we have the everything to the left and everything to the right side, because also we have to say rights.remove prices of I and lefts.add prices of I. So let's get rid of this for now. Okay, so let's do this. Print lefts and rights. So now you can see also, let's do the current. Okay, so we want everything to the left. Let's try to make this 2, and then the right is 3, 4, the left is 10. So without 2. So let's do this. Okay, so now if lefts, or if I is bigger than or equal to 1 and I is less than length of prices minus 1, this is the index constraint. Remember, we're only can't use the first or the last element in the prices array as the either end, right? only use the middle. So now that we have this, we can try to map this to the respective value. So 10, 100. So obviously 10 is less than 2, so this is not possible. So we have to find a triplet that has increasing values. So to do this, let's say b left equals to bisect left of left current, so we can only get this part. B right equals to bisect right inside of right current as well. Let's print BL and B right. Okay, and then let's say the left side is going to be lefts of up to BL, and the right side is going to be rights of everything from B right to the end. Let's print this. And let's also print the current. So this is going to get a bit messy. But okay, we have this valid triplet. So now that we have this valid triplet, we can just go through this list and find the maximum price associated with any of these triplets. Because we already know they're going to be less than the current, and this side's going to be bigger than the current. So let's say for L and LL, let's call this max left. Max left is the max of so we want to make this a sorted list, so let's add profits of I so we know that the list's last element is the biggest. And let's update DL -1 because that's going to be the last one in the value in the key of the dictionary's list. So same with right. Max right equals to max of max right, D right -1. And then at the end, we know we have the max price, so we can say the result equals to the max of result. And max left plus, it's not current now because this is just a value. We want to get the respective profit. So let's say, let's call this now is equal to D of current of -1 plus now plus max right. And then at the end, if result didn't change, then return -1, else we just return the result. Okay. Price is I, unexpected indent. Maybe we should add price is I. Where is the bug? 38. Okay, this is not supposed to be there. And okay. Okay, let's print lefts and her and rights. Okay, so, okay. This might be some edge cases, no, okay. Let's see how many test cases we pass now. Again, this is gonna be messy. 1806, fantastic, okay. So now I think we can just use the thing where if the length of prices is less than 100 and length of profits is less than 100, then just do the brute force. Same thing, triple loop. I is less than prices J, less than prices K. Then update the current sum. And if result equals 0, return -1, else return result. Okay. Okay, close. So this might not work for some really big edge cases, so small inputs you can just use brute force. Okay. Oh, wrong answer. Okay. For one test case. Okay. Lord. Okay. So now is the current -1, right? Perhaps this -1. Oh, geez. Okay. Profits of I. Right. This profit is linked to this price. Let's print D again. Okay. Something is wrong. Okay, I don't know. We're close though. Max left, yes. Plus now, yes. Plus max right. So result equals 0, return -1. Yeah, that should be okay. Why is this failing? Oh, okay, I think I know why. Because now we have to sort the keys of the dictionary, right? Because lambda x, because we want the biggest keys. So dict sorted, maybe. Again, this is going to be messy, so. Oh God, still no. Okay. Yeah, this question is quite a pain because there's so many different test cases. Oh my God, okay. Now we're gonna get time limit exceeded. Okay, fair enough. Okay. Oh, maybe you're just supposed to return -1. No, if result didn't change from the beginning. Return -1, else return result. That should be right. I don't know why this is not working. Again, let's comment this part out. So what is supposed to be this? Wait, isn't bisect left because we're supposed to get everything bigger than it? No? Okay. Okay, probably what's going on is that we want to make sure that there is a valid triplet. So first of all, left of 0 has to be less than the current, which is less than rights of -1 to even say this is valid, right? I think that's okay. Yep, that was what I missed, because just because you have this sorted list doesn't mean the current value is actually less. Okay. And this is supposed to be bisect right because we want to find everything bigger than the current in the right list and evaluate that. Okay. There we go. Jesus Christ. Yeah, this question is really tough. So, hope you guys enjoyed, but yeah, this is a real struggle. But thank you for watching and stay tuned for more.